All right, we're going to continue with our discussion of the skeletal system, finishing up with the appendicular skeleton. So we're going to start with the pelvic girdle, or sacrum coccyx is kind of where we finished off when we were looking at the spine. So looking first of all at, again, the sacrum and the coccyx. So the sacrum lies between the two large bones of the hip, which are called the ilium. We'll talk about those in a little bit. So we have the sacrum here and the coccyx. Now what forms the hip is a series of bones that are fused together. We can see they're color-coded here. This is just one half of part of the hip bone. This is called an os coxa, the whole bone, or coxal bone. We can see it's three different bones fused together. We have two os coxa, or two coxal bones, one on each side, and they are connected together in the front by a piece of very tough cartilage. In this region here, this tough cartilage that joins the bones in the front is called the pubic symphysis. So this is made of cartilage, and this cartilage will loosen during pregnancy, so a woman can deliver her baby a little more easily, because that opens up this outlet here for the baby's head to pass through. So this is the pubic symphysis. Again, if we look at the hips, it's a fusion of bones, but in general, when we compare the hip of a female to the hip of a male, we can see that the male pelvis is much more narrow. This angle here, this pubic arch, is less than 90 degrees. If we held this on a horizontal plane, we would find that this is less than 90 degrees. If we look at the female, it's greater than 90 degrees for this pubic arch. That's a real classic telltale sign of a female pelvis. Also, look at the opening here. This is where baby would come through. You can see that this is much wider, allowing for a baby's head. Also, the coccyx tends to curve inward in the male, where it's more flat in the female, so that's not in the way of baby passing through this pelvic outlet. That's another way of looking at these two pelvises. Another is, look at how far out this bone extends to the side. Females generally have wider hips than males do, just by their bony structure. That doesn't account for the fat that tends to deposit on the hips in females versus males, and that's because of estrogen that causes the different fat locations for deposition, or for depositing on our skeleton. But there are exceptions to the rule. There are males that have wider hips than females. There's females that have narrow hips. Sometimes that becomes a problem during childbirth, and some women have to give birth by a cesarean section because they just don't have the hip structure to accommodate a vaginal birth. So looking at, let's move back up to this previous slide, looking at the parts of the coxal bone. This large flanged portion of the coxal bone is called the ilium. So when you're standing forward and you put your hands on your hips, you're putting your hands on your ilium bone. So it's this portion is the ilium, this large flanged region. So all this that's shown in brown here is the ilium. The ischium is this lower portion here of the os coxa bone, or the coxal bone, and it's here. It's much thicker, so if you're actually looking at a true os coxa bone in lab, you'll feel that this is much thicker here. And this is because when you sit down, as your femur and your legs come forward to sit, you're actually sitting on this bony prominence here, and that's the ischium. So when you think of ischium, ischium has the S in it, and that's what we sit on. And the ilium has the L in it, and that's large, the large portion of this bone. So think ilium is the large portion, ischium is what we sit on, has the S in it, and the pubis bone is in the front here. So this is the pubis bone. It forms about, see this circle here? This is a foramen where nerves come through to serve the leg. But notice that this pubis forms one half of this circle, and that's this half here. This is the pubis on this half of the circle. And it conjoins or connects to the pubis on the other side, again via this special cartilage, a tough fibrocartilage called the pubic symphysis. So we have the pubis bone here. This is the pubis. Oops. Oops. And this is the pubis on this side. So the pubis begins here, stops right about here, and then the rest is ischium, So this is all ischium. And then this large flanged portion is the ilium. Now there's another structure you need to know, and that's this cup-like structure on the back side of the os coxa. This is called the acetabulum, and it's truly cup-shaped, and this accommodates the head of the femur. If we look at the femur, it has this large ball-shaped structure that will fit into the acetabulum of the os coxa, and that's what truly forms the hip joint. So we can rotate our leg in a circular direction because of this circular cup-shaped structure and the head of the femur fitting into that. The patella is not shown by itself as a picture, but if we look here, the patella lies at the bottom of the femur, and we'll talk about that when we get to the next part of the leg. But the next bone is the femur. I apologize, I was looking ahead of myself. So the femur is the upper thigh, the upper leg. It's the largest bone of the body. It's very thick, very strong, carries a lot of weight. A fracture of the femur is often serious, requiring pins and sometimes traction to hold those bones in alignment. It's a very, very large, strong bone. So at the top of the femur has, like I said, this rounded head with also a neck that extends that rounded head away from the bone itself. When we looked back at the humerus, remember that the humerus also had a rounded head, but that rounded head is right up against the top of that humerus. You don't see a neck on the humerus. So don't confuse these bones on the lab exam. The humerus does not have a neck. It just has the rounded head, but doesn't extend away from the bone like the head of the femur does. So here's the neck of the femur. And this is often what is broken when women with osteoporosis, as this femur weakens on the inside due to lack of calcium and weight-bearing exercise to build calcium and harden bone, what happens is the neck of this femur breaks, and that's what we call a broken hip. So what's actually broken is the neck of the femur, and that's what needs to be replaced. So that's the femur. Look for that large rounded head extending away from a neck at the top of the bone. At the bottom is where the knee would be located. This is the back of the knee. You can see there's a deep groove there. On the front it's a relatively smooth surface so that patella can slide right over the top. In this diagram here we can see the patella is just a small heart-shaped bone that lies over the top of the distal end of the femur. So that would be right here. We see a small heart-shaped bone lying over this end of the femur. So it looks like I forgot the tibia and the fibula. I'm going to have to add that into our PowerPoint here. I apologize. Let me go grab a picture of that tibia and fibula. The tibia is the larger bone in the lower legs. Students often get those two confused, saying the tibia from the fibula and trying to figure out which is which. The tibia is, like I said, the larger bone. Oh, looks like we have to go back a chapter. I'll go back one more chapter to chapter 5. So the tibia is the larger of the two bones. The tibia is on the medial side of the lower leg. So it's the larger bone, and when it is broken, sometimes will require pins to be set because it's an important bone for bearing a lot of our weight. So here's an example of the tibia. I'm going to drag this over. Let's see, it looks like I need to add a slide here. Alright, it looks like it doesn't want to allow me to do that, so let's see here. I don't know why it's not adding a slide. Let's see, we're going to go to Insert, a Slide. Not going to let me do that. I don't know if it's because I'm recording lecture or what the problem is here, but it's not going to let me do that. So I'm going to put it onto a Word document. I know that'll work. and we'll take a look at the tibia and the fibula there. So we'll drag that tibia and fibula over. So this is the bone of the lower leg. The tibia is a large, like I say, bone of the shin. So when you bump your shin, you're bumping the front portion of the tibia. So it's quite narrow on the front side of the tibia. And right above here is where the knee would be, or the patella would be located. So it's almost like a triangular shaped bone at the top, the tibia is. And this would be the inside bump you feel on your ankle. So if you reach down and feel the inside of your ankle, this is what you're feeling. You're feeling this bump on the bottom of the tibia. And when you get to general A&P, we're going to have to know a lot more detail on these individual bones, but for right now we're just going to identify the bones. So this is the tibia, the larger bone. It's on the medial side, on the inside of the leg if you're in anatomical position. Right alongside the tibia is the other thinner bone on the lateral side of the leg, and that's the fibula. The fibula is much littler than the tibia. So when you think of fibula, it has the L in it. Think of it's little, it's in the lower leg, and it's lateral. All of those can be clues to identifying the fibula from the tibia. Another phrase that I've heard students say is remember the little fibs, little fib. So that's another way to remember it, like a lie is a fib, so a little fib, if that helps. But it's on the lateral side of the leg. So that's the tibia and the fibula. The fibula is what is often broken when people break their ankle. You can feel this outer bump on the outside of your ankle. That is this portion of the fibula. And when a person rolls their ankle to the outside, typically they will either crack or break off the end of the fibula, and that would require the a cast or maybe a walking cast if you're lucky until that bone sets, because this is a very thin bone, fragile bone. It's easily broken when we twist our ankle to the outside. Lastly are the bones of the foot and ankle. So same thing as in the hand, but instead of the carpals we have these short chunky bones called the tarsals. So these bones of the ankle are the tarsal bones. Tarsals. Then we have these middle bones between the ankle and the toes. These middle bones are the metatarsals, just like we had the metacarpals in the hand. So this is what forms the most of your foot, the arch of your foot, the top of your foot. That's the metatarsals. Single bones, long bones in the foot. And then these last three bones, we can count 1, 2, 3. These last three bones, just like we saw in the fingers, they're the toes. They have the same name, the phalanges. So these are the phalanges. Notice that the big toe only has 2 bones, but still these are all the phalanges. So we have some rhyming words here. You've got the tarsals and the carpals and which is which. A good way to remember the difference between the bones of the foot and the bones of the hand, think that you clap with your carpals and you tap with your tarsals. So that'll help you remember which ones are assigned to the foot and which ones are assigned to the hands. So I would recommend that you label the skeleton diagrams throughout your lab packet on pages 20 through 25. Practice labeling, make sure you can identify the different structures from one another. Also be sure to get on the Mastering A&P website and complete the homework for lab. That'll help you identify the bones as well. And we'll be having our lab exam on this material next week. So you don't have to worry about the lab exam for this material until next week. Alright, that's all I have for today. We'll talk to you again soon.